All right. Hello, everybody. Um, I'm going to try to do this in just one take, so I apologize if at times I seem to get off track, but I have a few points I want to hit. I'm making this because I've seen lately a lot of questions about how to model thread accurately, or how to even model it just to where it looks good. So I wanted to go ahead and make this video because I've done it a few times now, and I feel like I've got a pretty good understanding of how it should be done. My name is William, and I've been working in an Autodesk Inventor for about 5 years now. And I've picked up a lot of little handy tricks, and I think my opinion on how to do this is valid. So first thing you need to do when you're trying to model thread is determine what profile you need. If it's a UN thread, if it's Acme, if it's metric, you need to figure out what thread profile you need, and you'll probably go online or consult Machinery's Handbook and find the profile for that thread. All the profiles are similar, but they all have their differences. So if you want it to be right, you need to go and find that profile and find the equations to determine that profile. It's also important to look before diving in to look at exactly how you need to model the thread. If it sits on a bolt, or if it's internal, or if something is fully threaded, it'll change a few things, like a fully threaded stud. If maybe the threads sit on the outside of a shaft that's a smaller diameter than the OD of the threads, or the major diameter of the threads, it will alter how you approach, but ultimately the execution is nearly the same. But it does change things just ever so slightly. There's also the idea of tolerancing. If you are very concerned with it, most of the time when I draw threads, I just draw them at nominal, which means I don't worry about 1, 2, or 3 for tolerancing. If you are concerned about that, you can go online and find the exact dimensions for the exact thread. If you want, 2B threads, or I'm sorry, no, 3B threads or something like that, you can go and find that. Find out exactly what the diameters are, the major and minor diameters, and you can make it work. That's about what you need to look at beforehand. I'm going to use UN threads. As you can see, I've got this bolt over here. This software is a little clunky, so while I'm rotating or spinning, it might not be very smooth, but I'm going to do what I can. So this is a 1-inch bolt. It's 5 inches in working length, and it has no threads on it. So I'm going to be doing UN threads. I'm going to do coarse threads. So for this size bolt, that is an 8 thread per inch. So it's going to be 1 inch 8 UNC. So first thing we're going to do is sketch our profile. So if your bolt or if your part is oriented such as this, you want a plane that cuts through it, similar to my XY plane here. For me, it could be my XY or my XZ. That would work as well. It cannot be this plane. The plane must be parallel to the center line of the part that you are about to thread. So I'm going to start a sketch here and try to move over here. It's not so bad. First thing I'm going to do, I'm going to go ahead and project that edge. Now, and I'm going to make it a construction line so that it doesn't affect my features. What I need is reference to the diameter of the part. I could do this just by dimensioning the thread profile and telling it what the major diameter is, but I like to reference this edge. So I know from my experience with UN threads, I understand the relationships. So I'm going to start by roughly sketching my profile here. And I am breaking these edges up into 3 lines because you sketch this full triangle, but it not the full triangle, or the entire triangle is not used. Only a portion of it is. So now, let me just make this easier to see. I'm going to make the outer legs and the top and bottom here construction as well, because they are not going to be used in my feature. And then what I need is straight lines across here that connect to their counterparts. Alright, so this will be the profile that we will cut away. I need to apply some dimensions here. I know with UN threads that this angle is 60 degrees. And actually, if I'm being even more accurate, this would need to be construction as well, and I will need an arc that connects these two. UN threads have a fillet down here at the base of the threads. So we'll make that tangent. I don't know if I need to tell it. Yep, I do need to tell it that one's tangent too. Okay, so now that I've done all that, many of these dimensions are going to relate to the pitch of the thread. Now, again, I know that it's a 1 inch 8 UNC, which means there's 8 threads per inch. The pitch is going to be 1 inch divided by 8. What I like to do when I'm setting up a part like this is I will bring up my parameters menu. I'm going to add one, and I'm going to call it TPI. I'm going to make this a unitless value, or unitless parameter, and I'm going to call it 8. This is going to be my threads per inch. I like to do it this way because I like to set it up so that I can change it if I want, and not have anything freak out. So after doing that, it's also easier to reference this rather than trying to do the equation over and over again, or having a parameter that isn't named, something that I can easily alter, or easily type in and remember. Anyway, so now I want to set up one called pitch, and I'm going to make pitch. It's going to be 1 inch divided by TPI, and you'll see over here now it says 0.125. That is my full pitch. So now that I'm done there for the moment, I'm going to come over here. You make the tip to tip of this triangle pitch. If you look at that, I happen to know that this leg is 0.875 times pitch. Again, this is from understanding the thread profile. And I know that this is 0.25 times pitch. Alright, so aside from any constraints, it looks like my profile is fully constrained. The last thing I need to do is attach it to the end here. And what I actually like to do, personally, is tell it that that line has a coincident there, so it sets the height. And then I'm going to, I'll put a point up here, because not all threads have this convenient round here, so I'll put a point at the center of that line. And then I like to tell this to be 1 pitch away from the actual material. That way the cut starts outside and cuts in, sort of like the cutting tool would, and it doesn't start, inside the material. It wouldn't look very good then. So now my profile is fully constrained. I am ready to make my coil. Now, again, depending on your tolerancing, some of these numbers might actually change. And what would probably happen if you were setting up a particular thread and you knew everything you needed to know about it, you knew the tolerancing, you wouldn't necessarily need these equations, because you'd likely have a table somewhere that will show you or tell you exactly what the size of, say, this line is, or maybe this distance here, based on the tolerancing, because the tolerancing will affect that. So now that I've done with that, what I'm going to do here is zoom out. What I want to do is create a coil. It's pre-selected my profile because it is the only visible closed profile in the part. I'm going to grab the appropriate axis, which in this case is the x-axis. I need to kind of turn this and have a look at it, and it's going to take me a moment. I believe that is right. That is the correct orientation. I cannot rotate. Okay, let's zoom in here. Yes, I believe that is correct. The bolt would turn to the right. Yeah. Okay, so set it to cut. This is the appropriate rotation and direction. Over to coil size. What I usually like to do is set this to pitch and height, because I know the pitch and I likely have a working thread length, which means I know the height of the coil. So pitch is going to be pitch. That's how convenient that is. height, I'm going to say it's a 5-inch working length. I'm going to say it's 3 inches. And if you remember right, my profile starts 1 pitch away from the end of the material, so I actually need to add 1 pitch. And ta-da! So there you've got threads cut into this material. And in some applications, this may be all you need. Depending on what you're using this for, this may be plenty. If you're doing renderings, you might want to go a little bit further with detail. If you're doing drawings and you really want to see that thread and you want it to look right, you'll probably need a few more details. I'm going to continue briefly here, just to demonstrate a little bit more of what you can do here. So there are different ways the thread can end. It can taper, where the cutting tool is retracted as the material is still spinning, and you get a little bit more of a cut as the profile tapers out. You can have a relief groove, which I feel like is more common than anything else. It's a groove that's cut into the material that allows the tool to move into that space and then is retracted, to where as it moves into that space it no longer cuts any material. And I'm sure there may be others as well, but for this demonstration, what I'd like to show you is the relief groove. So what I'm going to do is I'm going to create another, if I can roll this up, driving me crazy. I'm going to create another sketch on this plane. And this might get a little tricky. I'm kind of coming up with this off the top of my head. So I'm going to use this origin point that's been projected through. It's kind of convenient because that is the origin. Otherwise I would have to, and the origin happens to be at the end of my bolt. Otherwise I would need to project in some geometry to use as reference. So in this sketch, let me hit F7 to cut my geometry here. Now your relief groove size may change based on your part, and your threads and the cutting tools used, and it can change. So I'm just going to throw numbers at this relief groove in order to make it, consult whoever you need to find out if your relief groove, if you're machining this part, needs to be bigger or not. If you're just doing it for fun, you might not need to go into too much detail on it, and you can kind of make some numbers that would in theory work as well. So starting off, your relief groove looks kind of like a U in most cases. So you get this, and they can change in shape too. Sometimes it is very per thread. You get these filleted edges down here, and yeah, that's about the shape of it. So do I want to project, or do I want to? I'm going to do a different way of. I'm actually going to turn the visibility of this sketch on so that I can project from it, and I just want that point, the same one I used for the other profile. I'm going to turn that sketch back off. Now I'm going to create a coincident constraint to that point, and then what I want to do, let's do this. I'm going to create another custom parameter, and I'm going to call it thread length. No capitals. Inventor cares about capitals, so if I put one there, I have to put it everywhere, and I would just as soon not. So I made my thread length 3 before. Now up here you can see D18 says 3 inch plus pitch, and it also says it's consumed by coil 1. What that tells me is that that is the parameter I used to determine the length of my coil. So I'm going to make this thread length plus pitch. Now the thread length and the pitch are controlled down here, and it completely controls that coil. So the reason I did that is so that now I can come over here and I can put a dimension between this that edge and that point and call this thread length. And there you go. So now I know with all certainty that at any time with any change to the thread length, this relief groove will be in the right spot. Now I want to say you usually oversize your groove relative to this profile of the cut. So I'm going to say this is, right now I know that this edge, or this gap right here, is 0.875 times the pitch, as determined when I sketched out my thread profile. So I'm going to let this one just be pitch. that'll mean that I have 0.125 times the pitch of clearance. And I think I'm quite comfortable with that. In this direction, this one's kind of interesting because we made the height there. It was, that triangle was at 60 degrees, and let's just I'm just going to give it a number. Let's say it's 0.085. Yeah, I don't mind that. It's a little bit lower than the cut here, which I think is good. You want it to be a little bit lower so that the tool doesn't, it's not still cutting when it enters here. Now our radius, I want to say our radius is about as small as we can get it, but I'm sure with some companies they will they will cut that radius wider. I've heard that about a 32nd inch or 0.03125 about as small as the tools can typically cut, unless I don't know if you can get I'm sure you can get smaller radii than that on there, but for my purposes I'm going to leave it at that. So now I've got this fully constrained, fully dimensioned profile. What I need, I'll draw a line back from here. I don't really need to draw it this long, but I'll go ahead and make that a center line. It's the only profile here, so when I hit revolve, it's going to automatically put the profile in the center line. Now I just have to say cut, and there you go. Now, here's the other problem that I'm seeing here. This thread profile, the working thread length, stopped right there, and now that I'm looking at it, there's one other change I need to make, and then again, trying to do this all in one take on the fly. So here's my problem. I coiled the working thread length based on the center of the pitch, or based on the center of the thread profile. So what I probably need to do is kick this relief groove out so that you still get a full thread profile. I need to kick it out 1/2 pitch. So let me do that. We're going to edit this dimension, and I'm going to say plus 0.5 times pitch. So now it sits just beyond the last full profile thread, which should be your working length. And even a little bit further than that. Very interesting. Oh, yes, of course. I know why. It's because that top cut line is not the full pitch. So 0.5 times 0.875. Oh, sorry. 875 times pitch. That is what the top of my cut is. There we go. Now the last thread or full thread profile stops there. But the cut is supposed to continue into the relief groove, so for sake of simplicity, I'm just going to put my sketch on here. I have my full thread profile. I'm going to finish, create another coil, grab that. It wants the axis. Get my x-axis again. Now in this case, my coil size, the pitch can still be pitch. The height, I could probably call this pitch and be comfortable with it. It will line up in the right spot because the width of my relief groove was pitch. So going from here inward, it should land at the same spot. Oh, I need to cut, not join. So if I cut and do that correctly, and you get that, if I wanted to, I could turn on this sketch and use this D26 as to help me drive where this second coil ends. Now this is just for a relief groove. This second coil, you could skirt it by just making the first coil longer, by adding the relief groove width, or probably divided by 2, to that coil length. But having a second coil also gives me the option, if I don't have a relief groove, I could have this coil taper as though it was a tapered into the threads. And for the moment, I'm going to leave it as it is. So the last thing you might want to do when you're modeling threads for whatever purpose is we'll look at what I'm gonna do is chamfer this end whenever they're actually machined. Usually the edge of the bolt, which I'm just going to drag up into part 2 right there. So usually this edge is chamfered, so I'm going to go ahead and do that. And again, this kind of becomes I don't want to say related to the depth of the thread. I guess in this case, I'm just going to leave it at 0.125. This is just being for demonstration purposes. I don't really need that to be flexible. And if you're doing this and you're not doing this all the time, it's not something you're doing every day, then in all likelihood, you don't necessarily need this to be flexible either. So you can just put a number there. Now, I'm inclined with tutorials and with modeling and drawing in Inventor in general to make it to where I can change it, but it's not necessary for this. So there you go. I've chamfered my edge. The thread, I can't roll the part. It drives me nuts. Thread rolls into it nicely and threads down to its relief groove, and it stops there. I'm gonna make this look pretty. How about we do that? Let's do this. Let's make it polished. Looks nicer. Yeah, there we go. Maybe some shadows. I'll just do all, and then probably turn off ground shadows. Oh no, oh wait. Yeah, object and ambient. There we go. That looks sharp, huh? Maybe reflections. Nah, I'll get rid of reflections. This thing's already slow enough. Here I am making it worse. So, okay. There's one other thing that I want to cover. It was brought up in a forum post, and it was, I kind of wanted to just go over this. It's not likely what you'll need to do, but if you do need to do it, you'll want to know this. It's for multiple thread pitches, I guess is how it's phrased. I've seen it as phrased as single pitch threading and double pitch threading, or so on and so forth. What I want to show you is a way to make that happen, and then also how to make it flexible to where you can change it. We will start by going to our parameters menu, and we are going to make another custom parameter, and I'm going to call this I'm going to say in pitch. I don't know exactly what to call that one where it's going to make sense. I'm going to make this unitless, and we're just going to leave it at 1 for now. Let's make it 2. Trying to think ahead about if that's going to make anything mess up as I'm trying to integrate that, but I don't think it will. So then, all I have to do is come into my first coil, and I'm going to make it, and when I go to coil size, the pitch is going to be pitch times in pitch. So you see how now the coil is much wider. So when I press, or when I hit OK, you're going to get that. And that's not what it's supposed to look like. It's essentially to where you have 2 threads, the thread pitch is doubled and the piece is threaded. There's 2 thread paths, if you will. So now what I want to do, I want to do the same thing here on my second coil because I want this to all look right. So I'm going to go into this, I'm going to tell this it's times in pitch. Boom. So we're almost there. Now the trick is, and this becomes really neat to play with. We're going to do a circular pattern, a circular feature pattern. And I'll just grab my first coil and my second coil, and we will be patterning around the x-axis. And I'm going to say the placement, or the number of occurrences here is going to be in pitch. So now when I hit OK, there you go. So now see, this looks, you know, just at first glance, it looks exactly the same, but the thread, there's 2 threads wrapping around this instead of just 1. And that's really all there is to it. And now all my features will update, so I can come in here, and I'm going to pull this down so that you can see the thread in the background. And we're going to make this, let's say we start off by making this 10 threads per inch. So you see everything there updated. The only thing that didn't was my chamfer and probably my relief groove, though I did make some of that relate to the pitch. So that's why I try to make everything relate to one another, so that I can make changes like this, simple changes, and have the part update properly. So let's do, again, the chamfer, I could make it relate to the pitch. I would need to get the depth of the thread and make it add a predetermined amount. In the past I've done a 10% bigger. In other words, so depth of thread plus 10% to be the depth of the chamfer. I've also seen where people have done a number. They just say it's you know, 20 thousandths deeper, something like that. Both work. It just depends on how you do it and how your company does it. So, same with the relief groove. You could probably make it relate to the pitch, or the diameter of the thread, or diameter of the part, however, to where it updates. Mine doesn't do that right now. So anyway, let's go back. We'll make this something entertaining, like 20. Hopefully it doesn't fail. It did fail. Let's not do 20 then. And that's one of those things that I can work at. Oh, did I do? No, I did the right one, didn't I? Oh, I'm doing in pitch. That's why it's messing up. The TPI 20 didn't work either. Okay, alright, fair enough. We'll make this back to 10. And then why is okay. That's very strange that did those switch? Maybe I'm losing my mind. Anyway, let's try 12 for TPI. Okay. I might be losing my mind. So go back to 8. Now, what I wanted... Why is this moving? I swear I'm not losing my mind. TPI is jumping around. Okay. Alright. Okay. Anyway, so now let's change in pitch. If I change this back to 1, you see that, and you can kind of see it more in here. If you think of the edges, the peak of the thread as you see it come around here as being angled, that angle increases. That's really where you can see the difference. See that? So now if I make this 3 triple pitch thread, there it goes. God, I'm tired of these parameters jumping around. I'm going to watch it this time. It didn't move that time. But anyway, okay. So I just made it 4. So now you've got 4 threads, 4 pitch threads. I guess you could say 4 thread. I don't know. Anyway, so now we've got it to do that. Let's see, what else am I going to mention about it? This should still update, right? If I change the length to make it like 2 inches, should see that all shrink. Yep, that's still good. I feel like there was something else I was going to discuss, but I've hit all my... Oh, no, I know what it was. Okay. I've also seen this come up in the Inventor General forums, talking about 3D printing these threads as part of the incentive for modeling them. Otherwise, you would just use the cosmetic threads that Inventor provides, because it makes your models run faster to use that rather than model the threads. But if you're going to use these for 3D printing and you actually want to be able to thread something onto here, you can follow the same process, but what you're going to have to do is whatever your thread profile is, you wouldn't follow it exactly. You got to make it a little bit bigger. You have to cut away a little more material, and that you could try to figure maybe 5% more or something like that. You cut that away, and you'd probably have to print it and dry it. To be honest, I have not tried that. I just know that you would have to cut away more material because otherwise you'd be size on size. Or depending on the accuracy of the printer, it might bind up because it's not perfect if you don't give it enough clearance. So you essentially just give it more clearance to make up for inaccuracy in printing. And yeah, I think that's really the main reason, because if you're drawing the threads to spec, then your internal and external should work out okay. So let's see. Anything else? I'm really surprised that wouldn't go to 20 threads per inch. I was able to do that before, but if you do have 20 threads per inch, which is a possibility, you can do that. And there's probably something in there that's binding up that I'm not thinking about. It probably has to do, you know what I bet it has to do with? I bet it has to do with that relief groove, because I told it the radius of that groove. Let's try this. Just because I want this to be thorough and I want to make sure that I am... I can't do it. Suppress this. Suppress features. Okay. Now I just have my coils. I don't know why that wouldn't let me drag that, but that's okay. Now let's try... This jumped around on me again. Let's do a 10. Okay. Now go 12. Alright, so far so good. 15. I don't know if 15's a thing. I think 16 is. Good. It shouldn't really matter if it's a real thing or not, because the model should still work. 18. So far so good. 20. Okay, it was the relief groove. The reason the relief groove failed whenever I went to 20 threads per inch was because I gave it a 1/32 inch radius at the bottom in the cut, and whenever the top line of the relief groove updated to be 1 pitch in length, it was shorter than the radii I put together, so that the profile crossed over itself and failed. So that's that. And so yeah, if you have the relief groove to where it updates by the pitch, or at least the radius on it, to make sure it always works, then you should have no problem with that. In fact, I don't have enough time in this video. I'll have to make another video or something. Let's do like 6 in pitch though. We'll see what that looks like. It's slowing down. So here you're witnessing as my computer is slowing down because I've got so much studying in here. And if you were to put, even if this was, let's go back to 8 TPI, and let's go back to 1 thread per inch, or thread in pitch. Even if I were to just use this is a very standard size. And I put it all over a model and I had, a couple hundred bolts, it would slow down my computer tremendously rather than having cosmetic threads. So you really only model them when you have to, for a very specific purpose. But if you do have to model them, this is the way to go. This is how you do it. I've seen some other tutorials that are inaccurate in what I would consider proper ways to model threads, and I just wanted to put this out there so that I can just reference it anytime somebody asks. But here you go. Enjoy. If you're seeing this on YouTube, let me know what you think, and in the comments. And if you have questions, feel free to ask them. I'll be more than happy to answer. All right. Well, thanks for watching.